study reveals the age 50 turning point when your body's aging speeds up. Imagine waking up one day to find that your body's aging process has suddenly shifted into high gear. It's a frightening thought, but one that could become a harsh reality for many of us. The passage of time may be linear, but the way our bodies age is anything but. In fact, research suggests that our aging process is more like a roller coaster ride with sudden drops and steep inclines. But here's the shocking truth. There's a specific turning point when our body's aging accelerates, and it's happening sooner than you think. A new study has identified this turning point to be around age 50, and it's a game changer. After this milestone, the rate at which our tissues and organs age becomes much faster than in the preceding decades. And this is the part most people miss. It's not just a gradual decline, but a rapid acceleration that can have serious consequences for our health. The study, led by scientists from the Chinese Academy of Sciences, analyzed proteins in human bodies across a wide range of adult ages, and found that the trajectory of aging is steeper after age 50. But what does this mean for us? It means that our veins are among the fastest to decline, and that's a major concern. As we age, our risk of chronic disease increases, and this decline in organ function is a major contributor to that risk. The researchers collected tissue samples from 76 organ donors between the ages of 14 and 68 who had died of accidental traumatic brain injury. They covered 7 of the body's systems, including the cardiovascular, digestive, immune, endocrine, respiratory, integumentary, and musculoskeletal systems. By constructing a catalog of the proteins found in these systems, they were able to track how their levels. The results were striking. Expressions of 48 disease-related proteins increased with age, including cardiovascular conditions, tissue fibrosis, fatty liver disease, and liver-related tumors. The most significant changes occurred between the ages of 45 and 55, with the aorta showing a strong susceptibility to aging. But here's where it gets controversial. Does this mean that we're all doomed to suffer from rapid aging after 50? Or are there things we can do to slow it down? The researchers suggest that understanding how aging affects specific parts of the body at specific times could help develop medical interventions to make the process easier. And this is the part that sparks debate. If we can identify the exact mechanisms behind aging, can we develop targeted treatments to reverse or slow it down? The study's findings are poised to construct a comprehensive multi-tissue proteomic atlas spanning 50 years of the entire human aging process. This could facilitate the development of targeted interventions for aging and age-related diseases, paving the way to improve the health of older adults. But we want to hear from you. Do you think it's possible to reverse or slow down aging? Or is it an inevitable part of life? Share your thoughts in the comments below. The research has been published in Cell, and it's a must-read for anyone interested in the science of aging. So what do you think? Are you ready to take control of your aging process, or are you resigned to the fact that it's inevitable? Let us know in the comments. New blood test reveals your organ's true age, predicts disease risk. Imagine a world where a simple blood test can reveal not just your chronological age, but also how old your organs truly are, predicting your risk of diseases and even your lifespan. That's the groundbreaking promise of recent research published in Nature Medicine on July 25, 2025. In this study, scientists analyzed the levels of thousands of proteins in blood samples from about 50,000 individuals. By doing so, they were able to estimate the biological age of various organs. The findings are striking. When an organ's estimated age is older than the person's actual age, the risk of developing diseases and premature death increases. Conversely, a younger biological age of the brain and immune system suggests a longer, healthier life. But here's where it gets controversial. Some experts argue that while these tests provide valuable insights, they might also create unnecessary anxiety or false hope. For instance, what if someone's organs are biologically older, but they remain healthy? And this is the part most people miss. The complexity of aging involves multiple factors, and a single test can only offer a snapshot of one aspect. To delve deeper into the science behind this, let's look at some key references. 1. Lopez Otim, Blasco M.A., Partridge L., Serrano M., Cromer G., 2023, Hallmarks of Aging, An Expanding Universe. Cell 186, 243, 278. This comprehensive review article provides a deep dive into the current understanding of aging, highlighting the various processes that contribute to biological aging. 2. Rutledge J. O.H. Wiss-Carré T. 2022, Measuring Biological Age Using Omics Data. Natural Review Jeanette, 23, 715 to 727. This review focuses on the methods used to measure biological age, including the use of proteomics, which played a crucial role in the blood test study. 3. O. HSH et al., 2023, Organ Aging Signatures in the Plasma Proteome, Track Health and Disease. Nature, 624, 164 to 172. This paper details the development of the organ age estimation method using plasma proteomics and advanced machine learning techniques. 4. Sun B.B. et al., 2023, Plasma Proteomic Associations with Genetics and Health in the UK Biobank. Nature, 622, 329 to 338. This study analyzes the extensive UK Biobank data to explore the genetic and health associations with plasma proteomics. 5. Olin M. et al., 2015. Tissue-based map of the human proteome. Science, 347, 1260419. This foundational paper provides a detailed map of the human proteome, which is essential for understanding the protein profiles used in the blood test. These studies collectively underscore the potential of proteomics in personalized medicine, offering a new frontier in health assessment and disease prevention. However, as with any new technology, there are ethical considerations and potential misinterpretations to address. What do you think about the implications of such a blood test? Could it revolutionize healthcare, or does it raise more questions than it answers? Share your thoughts in the comments below. Your organs age faster at 50? New study reveals shocking truth! As we age, our bodies begin to show signs of wear and tear. But new research reveals that this process isn't uniform across our organs. A groundbreaking study published in Cell, https:/1016/jcell.047, has uncovered a critical shift in aging at around 50 years old, where the body's cellular machinery starts accelerating its decline. This discovery challenges the notion that aging is a gradual, linear process. Instead, it's a complex interplay of biological rhythms, with certain organs undergoing rapid changes earlier than others. The research, led by scientists at the Leibniz Institute on Aging, Fritz Lippmann Institute in Jena, Germany, highlights how proteins, the building blocks of life, undergo dramatic transformations over time. By analyzing tissue samples from 76 individuals aged 14 to 68, researchers identified 48 disease-associated proteins that accumulate with age, particularly in organs like the adrenal glands, which produce hormones crucial for metabolic regulation. These findings align with prior studies showing that different organs age at varying rates, with blood vessels and other tissues showing accelerated deterioration. Dr. Maja Oleka, a leading researcher in aging at the Institute, emphasizes that while the study confirms these trends, the exact timing of critical inflection points remains elusive. It's like a tide. We see waves of change, but the peak of each cycle isn't always clear, she explains. The study also suggests that blood vessels, acting as conduits for aging molecules, may transport harmful substances to other parts of the body, contributing to systemic aging. For instance, the aorta, the body's main artery, shows a dramatic shift in protein levels between 45 and 55, with one protein linked to accelerated aging in mice when administered. Such insights could pave the way for targeted interventions to slow cellular decay. However, experts caution that more research is needed before labeling 50 as a definitive crisis point. Discrepancies in findings often stem from differences in sample collection, population diversity, and analytical methods. As data accumulates, scientists anticipate that key molecular pathways involved in aging will converge across studies, offering a clearer picture of the body's aging mechanisms. The study's implications extend beyond biology, urging a deeper understanding of how environmental factors and lifestyle choices influence organ health. As researchers continue to map these processes, the quest to unravel the mysteries of aging remains a thrilling frontier, promising breakthroughs in longevity and disease prevention. Whether you're a scientist, a patient, or simply curious about your own body, this research invites us all to rethink how we approach the passage of time.